Good morning, dear students. In this video we'll solve one more problem on balancing of rotating masses. I suggest you to go through my previous video on balancing of rotating masses before watching this video. So the question is as below. A shaft running in bearings carries masses 20, 30, 40 kg in planes A, B and C at radius 30 mm, 20 mm and 15 mm respectively. The distances of planes B and C from A are 1000 mm and 2000 mm to the right of A. Relative angular positions of unbalanced masses are such that they are in static balance. Determine. To obtain complete dynamic balance, suitable masses are introduced in planes B, D and E with 100 mm from axis. D is 500 mm to left of A and E is 500 mm to right of C. We have to determine position and magnitude of balancing masses. So in this question there are three disturbing masses. A, B, C are the disturbing masses, and these three disturbing masses are kept in such a way that it is in static balance. So when the masses are not rotating, entire system is in balanced condition, but when it starts rotating, it will cause unbalance. So in order to bring the system back to balanced condition, we'll introduce two more masses, mass D and mass E. Now we have to find out what is the magnitude and what is the position of balancing masses mass D and mass E. So first we'll write a table, and in previous problem I told you number of rows in table, it depends on total number of masses. So in this problem there are 3 disturbing masses and 2 balancing masses. So my table should be having 5 number of rows. Different planes in this problems are, there is plane A followed by plane B, next plane C, and mass present in plane A, B and C are 20, 30 and 40 kg respectively. After this, radius value is also given. Radius value of A, B, C masses are 20, 30, 20 and 15 mm respectively. We'll write it in terms of meter. So these are the radius of masses A, B and C. In next column we'll write product of mass into radius. 20 into 0.03 you will get 0.6, 30 into 0.02 it is 0.6 again, and next value is also 0.6. So after this, before proceeding further, we'll draw the horizontal distance between each planes in the diagram. So in this question it is given that distance of plane B and C with respect to A, it is 1000 mm and 2000 mm to the right of A. So we'll mark those dimensions first. And I'm telling you again, this diagram you need not draw it according to any scale. I'm just representing horizontal distance between different planes. So let it be plane A, and plane B is located at a distance of 1000 mm and plane C is located at a distance of 2000 mm from plane A. So this is plane A. So this diagram represents horizontal distance between each planes, and apart from these 3 planes there are 2 more balancing planes or balancing masses are introduced in plane D and E. plane D is 500 mm to left of A and plane E is 500 mm to right of C. So we'll mark those two planes in this diagram. Plane D 500 mm to right of A to left of A and plane E 500 mm to right of C. This is plane D, which is located 500 mm to left of A, and this is plane E, which is located 500 mm to right of plane C. Now on left of plane A there comes plane D according to statement, and on right of plane C there comes plane E, and radius are given. Its mass is unknown, you have to find out. We'll write it as mass D and mass E. Its radius is 100 mm each. So in terms of meter, 0.1 meter. So product of mass into radius 0.1 times md, and here 0.1 times me. So after this you have to plot total 3 diagrams. 3 diagrams are: one is space diagram, one is couple polygon, and last one is force polygon. For constructing space diagram, couple polygon and force polygon, I need angular positions. Without theta value, without knowing inclination, you cannot plot any of the diagrams. But in this problem, angular position is not given in the question. Inclination of none of the masses are given. Therefore, you cannot construct space diagram, you cannot construct couple polygon or force polygon in this problem. And if you go through this question, there is one more statement called unbalanced masses are in static balance. So in these kind of problems, if none of the theta values are given, and also one statement will be there like unbalanced masses are in static balance, in such problem you have to plot one more diagram called static force polygon. And for constructing static force polygon, this is a type of force polygon, and for constructing force polygon I need these values. And according to statement, masses A, B, C are in static balance. That means these are the values corresponding to A, B and C. So using these 3 values will construct static force polygon. So we'll tell you how to construct static force polygon. So I told you for constructing static force polygon I need these 3 values, and since I'm having 3 values, using these values I can construct one triangle. Because I'm having only 3 values, so 3 sides will be there. So length of the first line will be 0.6, length of the second line will be 0.6 again, length of the third line is also 0.6, but inclination is unknown. So I will construct first line inclined at 0 degree and having dimension 0.6. Length of the first line will be 0.6, inclined at 0 degree. Length of the second line is also 0.6 again, but its inclination is unknown. So we'll construct one arc having radius 0.6. Since inclination is unknown, we'll construct one arc. And from this endpoint also again inclination is unknown, so we'll construct one more arc having radius 0.6. Now if I connect these 3 points, that completes static force polygon. So here first line represents mass A, second line represents mass B, and third line represents mass D. Now from this static force polygon, I can find out what is the inclination of mass B as well as inclination of mass C. So this line represents mass A, and to find out inclination of mass B, I told you always you have to measure angle with respect to horizontal. So mass B is inclined at 300 degree, and this line represents mass C, and you have to measure angle with respect to 0 degree line. So this total angle will be inclination of mass C, and if you measure this angle you will get 240 degree. So we'll write inclination of mass A, will assume it as 0. Inclination of B, you will get inclination of B as 120 degree, and inclination of C as 240 degree. This is using static force polygon. After this static force polygon, now let me fill the fifth column of this table, distance from reference plane L. So in this, which one you have to take as reference plane? I told you during my previous problem, you have to select a plane in which I am having unknown mass as reference plane. So I am having mass D which is unknown in plane D. So this will be the reference plane. Now write distance from each plane with respect to plane D. Now we'll write horizontal distance, or distance to each plane with respect to plane D. So distance from D to A, it is 500. Distance from D to D will be 0. Distance from D to A, it is 500, 0.5. Again from same diagram, distance from D to B will be 1.5 meter. D to C you will get 2.5 meter, and distance from D to E will be 3 meter. This is by referring same previous diagram. Now in last but one column, we'll write product of M into R and distance from reference plane. So something into 0 you will get 0. This will be 0.3, 0.9, 0.6 into 1.5 you will get 0.9. Here 1.5 you will get, and this value will be 0.3 times M into E. So after this you have to plot two more diagrams. One is couple polygon using these values, and force polygon using these values. And I told you how to identify whether to start with couple polygon or force polygon. You consider this column. Using these values will construct couple polygon, and in this column I am having only one unknown. So you have to start plotting couple polygon or force polygon based on in which column I am having least number of unknowns. Since I am having least number of unknowns in this column, first I will construct couple polygon. So we will tell you how to construct couple polygon now. Here length of the first line will be 0.3, inclined at 0 degree. In couple polygon, length of first line will be 0.3, inclined at 0 degree. Length of second line will be 0.9, inclined at 120 degree. Inclined at 120 degree. Length of the next line, third line will be 1.5, inclined at 240 degree. Inclined at 240 degree. you will get like this. You have to take suitable scale while constructing this diagram. And if you connect, next value is unknown, 0.3 times me. So if you connect starting point with end point, if I connect starting point with end point, measure this dimension, you will get 103.92 mm, and you have to equate this value with 0.3 times me. So here I will write 0.3 times me is equal to, this is 103.92. So by simplifying this, you will get value of me. So value of me you will get by taking suitable scale again, you will get 3.47 kg. Value of me will be 3.47 kg. And if you need inclination of me, this line represents me. This is the starting point of line and this is the end point of the line. And I told you always you have to measure inclination at starting point with respect to 0 degree line. So draw one horizontal line here and measure inclination with respect to horizontal. So you will get angle 30 degree. So 30 degree is the inclination of mass E. So you will get me as 3.47 and its inclination will be 30 degree. Now last one value is pending, md is pending, and to get the value of md we'll construct force polygon. We'll tell you how to construct force polygon now. And for constructing force polygon I need these values. Length of the first line will be 0.6, inclined at 0 degree. Inclined at 0 degree. Length of second line, it is 0.6 again, inclined at 120 degree. From this end point, length of second line 0.6 again, inclined at 120 degree. And length of the third line, it is 0.6 again, inclined at 240 degree. But if I construct this 0.6 inclined at 240 degree, what happens is this triangle will be closed. So instead of going for 0.6 now, we'll go for next value 0.1 times me. So 0.1 times me, you will get 0.347. When you multiply value of me, you will get this value 0.347. And its inclination is 30 degree. So length of the next line will be 0.347 and inclined at 30 degree. After this, we'll go for next value 0.6 inclined at 240. Next value, length is 0.6, inclined at 240 degree, or else you can construct parallel to this one, parallel to this. Now if I connect starting point with the end point, this is the starting point with end point, and you have to equate that to 0.1 times MD. So measure this dimension, you will get 17.35. So 17.35 is equal to, you have to equate that with 0.1 times MD. Take suitable scale factor. When you simplify, you will get MD value 3.6 kg. And to find out inclination of MD, at starting point, draw one horizontal, and you have to find out inclination with respect to 0 degree line. This will be the inclination of mass D. When you measure this inclination, you will get theta D as 212 degree. 212 degree. So this angle will be 212, and mass of D you will get 3.6. Now I can construct one more final diagram here, that is space diagram indicating position of all the masses. Space diagram. For constructing space diagram, I need radius and also inclination. So first mass A, its radius is 0.03. Inclined at 0. Second mass, its radius is 0.02, inclined at 120 degree. Second mass having radius 20, inclined at 120 degree. This is mass B. This is mass A. This one is mass B. And next mass C, its radius is 0.015, inclined at 240 degree. Inclined at 240 degree, or else parallel to this one. So this is mass C. And you have to represent two more masses, mass D and mass E. Radius of mass D is 0.1. Inclined at, inclination of mass D is this one. So parallel to that. Parallel to this. This represents mass D. Here comes mass D. And the last mass, mass E, parallel to this one. Its radius is 0.1 again. So parallel to this one. inclined at an angle of inclination of mass E is 212 degree. So somewhat like like this you will get. This will be mass E, the last mass E. So that completes solution for this problem. Complete this table, note down all the angular position value also. So that completes complete solution for this one. Thank you.